Have you ever heard about the death of a star and what it's like to actually see one? The James Webb firsts keep coming, with the new space telescope having recently spotted what could be the most distant galaxy ever observed. Now, it may have spotted its first ever supernova, or in simple words, a dying star. So, what exactly did James Webb see when it observed the very last hurrah that occurred when a star ran out of fuel? Let's talk about it. Welcome to Space World. In today's video, we are going to talk about the first ever supernova spotted by James Webb Telescope. So if you want to know more about it, then stay with us until the end of the video. The James Webb Space Telescope has been breaking new ground with each passing day as scientists and astronomers pore over the data returned by the Space Observatory. According to its creators, it is one of the most powerful telescopes ever built in the history, and it can look back in time. As one new group now suggests, the telescope may have already captured evidence of its first record supernova, or in layman's terms, the death of a star. During this event, astronomers spotted something unusual happening in a distant galaxy in recent images from the James Webb Space Telescope. Something that wasn't there when Hubble last looked at the same galaxy. We suspect it's a supernova, astronomer Mike Engesser of the Space Telescope Science Institute stated. Finding short-lived cosmic events like supernova isn't what Webb was designed to do, but the newly operational Space Telescope seems to be full of surprises, and this one could open the door for looking for the death throes of the universe's first generations of massive stars. But what's new about this supernova? Well, Engesser and his colleagues say the bright object is probably the first supernova spotted by the Webb telescope. It's extremely bright compared to the rest of the galaxy, for one thing, and Webb observed the galaxy called SDSS.J141930.11 plus 5251593 twice, 5 days apart. The object dimmed just slightly over those 5 days. Classic supernova behavior. We would need more time series data to make a determination, but the data we do have does match that of a supernova, so it's a very good candidate, says Engesser. The galaxy, whose unwieldy astronomical name we won't repeat, is between 3 and 4 billion light-years away. So astronomers are seeing the slowly fading light of an explosion that happened 3 to 4 billion years ago. The actual death of a star takes a fraction of a second, but the resulting fireball takes days to grow and brighten, then gradually fades away over the next few months. That's a blink of an eye in astronomical time. So it's sheer luck that Webb happened to spot this supernova shortly after its brightness peaked. Primarily, it's exciting because we have shown that we're able to find and detect new transients with Webb, which was something that JWST is not designed to do, says Engesser. But it's one of the things we're showing we're able to do in a sort of an ad hoc way. Even as versatile as it is, Webb isn't the kind of telescope astronomers typically use to hunt for short-lived objects like supernovae. Most of the time, that work is done by ground-based telescopes here on Earth, which image wide swaths of the sky every night. Webb, on the other hand, looks much deeper into smaller patches of sky. The telescope's first deep field image, released on July 12, covers an area of sky that you could cover with a grain of sand held at arm's length. So the actual likelihood that you'll find a transient in the field you're looking at is fairly small. Or at least we thought it would be small, says Engesser. But as you've probably heard, every JWST field is a deep field at this point. So there's galaxies everywhere. And now we're thinking, oh, we might have a really good chance of detecting supernovae all the time. The Earth-based telescopes that usually look for supernovae take images of the same wide areas of the sky every few nights. Their data processing software compares every new image to the previous images of the same area, looking for anything that might have changed. To do the same thing with space telescopes, Engesser and his colleague compared new data from Webb's NIRCam instrument to Hubble images of the same area. they used software to look at any differences that might reveal what astronomers call transients, objects that appear, vanish, brighten, or dim on a timescale we can actually see in real time. That's how the team found the supernova. It's also how they located a supernova that flared to life in 2013. Astronomers knew about that one, called 2013 EJ, but its once bright fireball has long since faded too much for most telescopes to see it. There's a lot of questions about this particular object and what type of star it was and its environment, like how dusty it is. It seems like it's very dusty, says Engesar. Because supernovae tend to fade over a few months, astronomers don't usually get to see their much later stages. We could offer more clues about what type of star exploded along with the physics of that stellar explosion. Webb's deep view of the universe could make the aftermath of a supernova like 2013 EJ easier to track even several years later. So observing this now with Webb is actually really cool as a way to investigate the super late environment around big, bright supernovae like this, says Engesar. We're getting new insights that we have not been able to get before. In addition, Engesar calls both detections, the newly discovered supernova and the fading one scientists had lost sight of, proof of concept. He and his colleagues are part of the Transient Science Space Telescope research team, led by astrophysicist Ori Fox at STSCI. Fox's team wants to use Webb to look for supernovae in the oldest, most distant galaxies in the universe, the kind that even Hubble has trouble seeing. If we can detect new things, then that lets us do these sort of very fast turnaround target of opportunity proposals, where we detect something and then we can say, okay, interrupt everything else. We want to observe this thing right now. This is time sensitive, explains Engesar. Once we have a nice repertoire of supernovae built up, we can say, okay, it's actually very worthwhile for us to have these time-sensitive observations of super high redshift supernovae. Now, why does this discovery really matter for the James Webb Space Telescope? Old, distant supernovae could help astronomers better understand the very fabric of the universe and how it's stretching and expanding over time. Most physicists now agree that the universe is expanding, and that expansion is speeding up. That's thanks to a 1998 study that used a specific type of supernova to help measure distances between objects in the cosmos. These supernovae, called type Ia supernovae, happen when a white dwarf star in a binary star system steals so much material from its companion star that the greedy white dwarf collapses under its own mass. So, because type Ia supernovae are always the same brightness, astronomers can measure how bright a supernova appears in order to calculate how far away it and its host galaxy are. Astronomers call objects with known brightness standard candles. By looking at the redshift of these supernovae, you can measure how fast they're moving away from you, as well as how far away they are, explains Engesar. So one of the things we want to be able to do with Webb is to detect super high redshift supernovae to even more constrain the cosmological nature of the universe and how it's changing over time. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.